Hello students, welcome to the continuing series of videos on bit string flicking. And next what we have in this video is four more operations, and these are a little bit more complicated than the first four that was introduced in the previous video. So let's get right to it. The next operator that we have here is what's called the left shift, and what this does is it moves all of the bits one spot to the left and then fills in the rightmost spot with a 0. Well, let's write that down. Okay, so whatever bit string you had before, you shift everything to the left one spot, and then you fill in that blank spot with a 0. And the symbols that are typically used are as follows. People typically say L shift, and then they'll indicate some sort of number here. Or they'll put some sort of number in here to indicate how far left to move it. When you're programming, it is the double less than sign. So this says push everything to the left. Okay. So this is really necessary to take a look at an important example. Okay, so let's say I had this string 01101, and then I wanted to left shift it with just one spot. So this is like saying, okay, and this one here, it's not a negative one, it's a dash here. So it says to left shift one spot. And following the example that we had before, what we're going to do is notice that this here is a 5 unit or a 5 character bit string. So when you shift it to the left one spot, it's going to become a 6 unit bit string. So it's like you're saying you have 1, 2, 3, 4, 5 spots. Well, now you still have those same spots, 1, 2, 3, 4, 5. Okay, and then you still fill this in with exactly what you had before. And now you have another spot. So each one of these spots has been each one of these bits has been shifted once to the left. And now you have this empty spot right here, so that needs to be filled in with a 0. Filled in the rightmost spot with a 0. And it is pretty straightforward. It is that simple that you just take everything. You basically just add a 0 to the end of this. Okay, that's essentially what a left shift is saying. If you had left shift 2, you would add 2 zeros to the end of it. So along those same lines, we have the right shift operator, which does basically the exact opposite. It moves each bit one spot to the right and essentially removes the rightmost bit. Okay, so move everything to the right and remove the rightmost bit. And the notation or the symbols that people usually do for this is, well, instead of L shift, we have R shift. And then usually some number that gets filled in here into the blank, or if you're writing code, you would do something like that. Okay. So again, maybe we should take another example. So let's say I take the same string that I had before, and I want to shift it one spot to the right. So again, if you just imagine that you had these blank spots here, 1, 2, 3, 4, 5, and you're taking each of these and pushing it once to the right, so removing the rightmost bit. So you basically get rid of this bit, and then the numbers that you have left is 0, 1, 1, 0, and this empty spot here, you fill it in with another 0. Okay. And that's basically all there is to it for left shift and right shift. Just left shift, push everything to the left one spot, fill it in with a 0. Right shift, push everything to the right one spot, and fill this in with a 0 here. Now I'm using 5 bits so that it's easier for us to see. Most computer systems, depending on the architecture, but many of them will probably use 32 bits. Okay, so that's the end of that. Let's go on to the last two operations here that we're going to work with. One is called the left circulate, and the other is called the right circulate. So the circulate operators are very interesting. So this left circulate basically means to take the leftmost bit and move it to the far right. Okay. So take the far left bit and move it to the far right. And the symbols that are typically used for this is, well, L circ, and then usually some number that follows in here as well. It's sort of like left shift and right shift. And the number will indicate how many times to repeat the operation. So let's look at an example. Okay. So if I have the same bit string that I had before, 0, 1, 1, 0, 1, L circ basically says take the leftmost bit, that's this one, and move it to the other side. So move it over here. So now this becomes 1, 1, 0, 1, 0. And let's just maybe do another quick example so that you can see if we were to do this twice. Okay. So repeating what we had before, take the leftmost bit and move it to the end. And then do it again. Take the leftmost bit and move that to the end. So now our new string is 1, 0, 1, 0, 1. And of course, the analogous feature to this, or the counter feature to this, is the right circulate, which is take the rightmost bit and move it to the far left. Okay. And then the symbol for this is typically R circ with a blank, and that's usually filled in with some sort of number. So here's a quick example. We're going to perform R circ 3 times. So take the rightmost bit, move it to the leftmost side, rightmost bit, move it to the leftmost side, rightmost bit, move it to the leftmost side. So now our new, I'm sorry, this is a little bit scrunched up here, but our new result is 1, 0, 1, 0, 1. Okay. And let me give you a more interesting example now. Okay. What if I wanted to take this string and perform R circ 87 times? Okay, 87 times. So, you know, let's think about this a little bit. I mean, we don't want to just do the brute force method, because that is not what good computer scientists do, and not only that, it's probably time consuming and it will be error prone. Okay. And notice here for R circ and L circ, the bits never get destroyed. All they do is get shifted around. So this is what I like to think about. You know, I think that if we were to perform R circ once, then this bit goes over here. So imagine with me, if we were to perform R circ once, then this one right here becomes the leftmost bit. If we were to perform it twice, then this becomes the leftmost bit. 3 times, then this becomes the leftmost bit. 4 times, this becomes the leftmost. 5 times, this becomes the leftmost. In other words, after 5 times, okay, we're back to where we started. So if we were to perform L circ 5 times, we would get the exact, R circ 5 times, we would get the exact result that we started before. So let's not just imagine, let's do it, okay? So we perform R circ once, this bit goes in front, twice, this goes in front, 3 times, this goes in front, 4 times, this goes in front, 5 times, this goes in front. And as you can see, if we perform R circ 5 times, we're back to where we started before. So what that means is that if we perform R circ 10 times, 15 times, in other words, any multiple of 5, okay, we get the exact same thing that we started before. So, if we were to perform R circ 87 times, after 85 times, because that's a multiple of 5, we end up where we started before. And so this is the equivalent of R circ 2. Okay. So doing this 87 times or doing this twice gets you the same answer. So we can just do this twice then, that's much simpler. We do it once, the 0 goes in the front. We do it once more, the 1 goes in the front. So now we get 1 0 1 0 1. Okay. So there you have it. This is some good examples of how to work with left shift, right shift, L circ and R circ. And maybe you can think for me, some general rules to R circ. Like, what if this was a string of length 17 and we had to perform R circ 87 times? How would we do that? Okay. So I'm going to end this here. The next video we'll look at some examples where we combine some of these features together.